Hello grade 11s, welcome back. We're still doing maths again, and today we're focusing on analytical geometry. All right, but before we get to your analytical, and you all know me, it's Mr. Sishe. Let's now proceed. I want us to look at the terminology first before we go into your analytical geometry, right? You did it in a little bit in grade 9, and then you did some in grade 10, and then now we're trying to extend it a little bit in grade 11. All right, so what I want us to look at today is, on your terminology, what do the following terms or words mean? Your gradient, your distance, your straight lines, parallel lines, perpendicular lines, midpoint, and your collinear. All right, so I'm going to give you, again, your 2 minutes to work out just roughly. You can give a definition of the word, or you just give an example of that particular word. So take 2 minutes and look at these words. Well done, boys and girls. I can see most of you are also drawing pictures. It's very important when you're doing analytical geometry or coordinate geometry to actually have some pictures as well. So now if we are looking at, I'm going to draw a picture myself here. So this, I'll have a line here, all right? And then I can have maybe another line going that direction. Right, then when we're looking at the steepness of these lines, it's going to be different. But how do you work out the steepness of that line? It's the gradient. It's always a change in y over change in x. So your gradient is represented by change in y over change in x, which at this point, if we're looking at this line, it can have maybe 2 points there. You can work out the gradient. Let's say this is x, and then that's y. This is x and y as well. But these are two sets of coordinates. This is set 1, that's set 2. Then this is x1, y1, and then that will be your x2, y2. Now the change in y is a reminder from last year. That's going to be your y2 minus y1 over your x2 minus x1. So that's how you work out your gradient. And now, again, guys, if you look at your distance, for instance, I can have a Cartesian plane again and have a point here, point A, and then point B there. I can ask you to work out the distance between those 2 points, all right? Now, For a horizontal one and a vertical, it's easy to just calculate, work out the blocks and whatnot. But if you have a situation like this, if I give you maybe that's your point A and then your point B. Now, you've got x is negative on your point A and y is negative, B, x is positive, y is positive as well. But you need something that will help you out to work out the distance. And the distance is given by d squared, it's equals to x2 minus x1 all squared plus y2 minus y1 all squared. Or sometimes other books will just say d is the square root of, okay, because taking from there, solving for d, you will have d equals to plus or minus the square root of x2 minus x1 all squared plus y2 minus y1 all squared. But we all know that the distance is always positive. You're not going to tell me, no, Ish, I ran negative 16 kilometers and whatnot, right? So you can say something like, okay, it was 16 kilometers in a different direction and whatnot, but we never use a negative, okay? So that's your distance formula. And then with your straight lines, okay? In this grade, you'll be talking about your parallel lines and your perpendicular lines, all right? Now, we'll get to the activities just now. But if I just draw a picture like you guys are doing, these two lines, okay, it's a rough sketch. This is your x, that is your y. If the distance between, this is your AB, and then that's your CD. There's line AB, and then there's also line CD. If the distance apart throughout, it's the same, like this is 4 meters apart and all the way. So those lines are parallel, but we sometimes say they will never meet, but we'll get to that topic later. So now, but what we always know is that they will have the same gradient, those two lines. So for parallel lines, gradient of the first line, which in this case is AB, is going to be equal to the gradient of CD, right? Now, if the gradient of AB is 5, then the gradient of CD is also 5. And then remember in grade 10, it was evident that when you are working with perpendicular lines, this is your x, and then that's your y. For instance, I have a line like this, and then I'll have a line, okay, I'm trying, it should be perpendicular to that, right? So if a line, say line AB is perpendicular to line CD, for instance, okay. Now guys, we know that the product of the gradients, your gradient 1 times gradient 2, it's equals to minus 1. So you must always note that the parallel lines, they will share the same gradient, but perpendicular lines, the gradient of the first line times the gradient of the second line equals to minus 1. And then you'll come across a word, or it's collinear. They'll be talking about points, right? So now if you're given a line, for instance, right? This is line A, B, okay. So that's your Y, that's your X, right? So you've got those points. If they are saying, prove that, for instance, points A, B, and C are collinear, what do they mean? It means that those 3 points should be lying on the very same line. How do you tell if they are collinear? If they are on the same straight line, it means that they will be sharing a gradient. Now, what do I mean by that, right? So the gradient of AB, so gradient AB, it's going to be the same as the gradient of BC, and also the same as the gradient of AC. So if I work out the gradient of AB to be a half, and the gradient of BC to be a half, and the gradient of AC to be a negative half. So it means that those points are not collinear. It's just a simple example. But if they all, we all getting a gradient of AB is a half, BC is a half, and then the gradient of AC is a half, then those points will conclude by saying they are collinear. All right. So now let's get to some bit of revision, okay? So we've got this question. A is minus 2 and 1, B is 3 and 3, and C is 6 minus 3 are the vertices of a triangle, all right? Now, okay, so the picture was drawn for you, all right? So you've got A, B, and C. Now you need to determine the coordinates of M, the midpoint of AC. Okay, we didn't touch on the midpoint, but if I were to draw you something like this, this is A, B, and then maybe you've got K there. You know that this can be represented by, this is X1, Y1, then that's your X2, Y2, right? So that point K, is in the middle. It's between, right between A and B. Now, how do you work out the coordinates of that point? It's halfway through, right? So you will have your midpoint is given by the average of the two. So X1 plus X2 all over 2, right, is to your Y1 plus Y2 all over 2. So that's your midpoint. And then I would like you to work out the coordinates of the midpoint, the gradient of AC, and the equation of the line perpendicular to AC and passing through M. This is called the perpendicular bisector. Just a reminder that that line that bisects it, it's a perpendicular bisector. Okay, so I'm going to give you this problem. You take some time. We'll go for break. And then when we come back, we tackle this question. Welcome back, guys. At least most of you are working. And I can see that most of you have done A, B, and C. That's wonderful. All right, but let's look at the question, the questions together. All right, the first question. All right, determine the coordinates of M. All right, coordinates of M, the midpoint of AC. Now, it's very wise to actually go to the picture itself and make a rough, like you roughly check where that point is, okay? So now if we look, all right, so this is point M. Wow, this is very nice for you guys. They've worked it out for you. But let's work out what your coordinates of M can be, all right? So the midpoint of AC, we said that point is halfway through. So your midpoint is given by, that's your M, X1 plus X2 divided by 2 is to Y1 plus Y2 all over 2. Okay, right. Now, very important, grade 11s. You giving your coordinates a name. So, for instance, this you can say this is a set 1. That's your second set of coordinates. Then that will be your X1. Then that is your Y1. This is your X2. And that is your Y2. Okay. Right. Now, it's just a matter of substitution here. So your M bracket X1 is negative 2. And then X2 is 6. So negative 2 plus 6 all over 2 is 2. Y1 is 1, and then Y2 is minus 3. So 1 plus minus 3 all over 2. Okay? And then which simplifies to, you have now your M is minus 2 plus 6, that's 4 divided by 2, it's 2. And then 1 minus 3, that's minus 2, over 2, that's minus 1. So your coordinates of M, it's true that it's 2 and minus 1. Right. And then we move on, we work out the gradient of AC. Right? Now, we discussed earlier that, reminding you that the gradient is given by the change in y over change in x. So that is your y2 minus y1 all over x2 minus x1. So in other words here, the gradient of AC will be your y at C minus y at A all over x at C minus x at A. Okay? Now, y at C. Guys, please make sure that when you are identifying the the coordinates, right, you go straight to those coordinates, you don't mix them. If you have used y at C, then you have to go to the y at A and so forth, and don't mix the x and y. Sometimes we get a situation where we have the x is the numerator and the y is the denominator. It's the change in y over change in x. So y at C is minus 3, minus y at A, it's 1, so minus 1, all divided by x at C, it's 6, minus x at A, it's minus 2. Now, very important, we always get a situation whereby you have seen a picture and you have all these coordinates correctly, but when you substitute, you say 6 minus 2, and which is going to make your problem wrong, because you've got 6 minus what is the actual value at that coordinate. It's minus 2, and it's going to be changing the sign there. So you've got minus 3 minus 1, which is minus 4, divided by 6 minus minus 2, that's 8, which is negative half. So the gradient of AC is a half. So we've answered that question. I hope you guys are still fine, right? And then now, you need to determine the equation of a line perpendicular to AC passing through M, all right? Now, this is key. Perpendicular to AC, right? Now, we just go back a bit. What did we say about perpendicular lines? So the gradient of the first line times the gradient of the second line equals to minus 1. Okay, let's go. Gradient of the first line times gradient of the second line equals to minus 1. Do we know the gradient of AC? Yes, we've worked it out. M is negative half. Okay. Now, the gradient of the second line. Now, go back to your question. Determine the equation of a line. So we determine we're determining. Okay. We're working out the equation of a line that is perpendicular to AC and passing through M. And now remember, guys, at the end of the day, you have to have your equation in a standard form, which is the equation of a line y equals to mx plus c. But you are now in grade 11, you will also be using the equation y minus y1 equals to m into x minus x1. Right, so you've got m1. You can substitute. Now, can you see that you're going to have the unknown, which is only the second gradient? Okay, let's substitute. This is minus half times m2, it's minus 1, all right? Now, I'm dividing by 2. I can get rid of that 2 by multiplying throughout by that 2. So I've got minus m2 equals to minus 2. I've multiplied by 2 throughout, but I want to get m on its own. So I'm still going to divide by a negative 1, or rather multiply by negative 1. So m2 is 2. Okay, so we've got the gradient. But our main final destination is to get the equation of a line. And bearing in mind that at the end of the day, we're going to have y equals to mx plus c. So we're going to have a gradient, all right, and also the y cut there. All right, so we continue. Again, they've told us it passes through M, and M is 2, 2 minus 1. So we've got the coordinate M, 2, and minus 1, all right? So now, you can now easily work out the equation. So y minus y1 equals to M into x minus x1, right? Now, where do we get all these x1s and the y1s? Now, with this equation, it's still the same as your y equals to mx plus c, but when you're working with this equation, at least you are knowing that you are working with a set of just one coordinate. Okay, so this will be your x1, and then that will be your y1, okay? So now you'll have y minus the y1 is minus 1 equals to m. Now the gradient of the new line is 2. Remember that other one was negative half. So x minus x1 is 2, right? And then from there, you can see that it's not yet on your standard form. So you simplify this. This will be your y plus 1 is 2x minus 4, right? Now you have to make sure that at the end of the day, you have your y as the subject of the formula. So you have y equals to 2x minus 4. Now there's a plus 1. How do you get rid of that plus 1? You subtract a 1 on both sides. So I'm going to subtract a 1. So I get y is 2x minus 5. So y is 2x minus 5 as our final equation of a line that is perpendicular to AC but passing through your M. All right. Now, I think we have not yet answered. There's some questions, just check. Okay. Okay. It's now freezing, but let's move on. Okay. The next question. Determine the value of values of y if the distance between minus 7y and minus 3, 4 is the square root of 80. I'm going to give you 3 minutes to work on your own or with a partner, and then you work out what is the coordinate of y or coordinates of y that's the distance between those 2 points, but you're getting the distance to be the square root of 80 units. So let's take 3 minutes and work on this problem. Well done, guys. Let's see if you're getting the correct answers. Okay, now the question is determine the value of values of y if the distance, now the keyword here is the distance between those 2 points, minus 7y and minus 3, 4, is root 180. And it's always, sorry, wise to actually have a picture, right? So you've got minus 7, and there's minus 3, 4. So there's this point, okay? Minus 7 and y. Minus 7 and y, you can have it somewhere there and whatnot. But you are saying this is minus 7 and then y. But the distance is root 80, okay? Or where is this point? And then y can be, sorry, you can draw it down there, but then you've got minus 7 and then y. My picture is very moronic. Let me just erase it. Okay, but so you've got minus 7y and minus 3, 4, right? The distance is root 80. Now we know that working out the distance is given by the square root of x2 minus x1 all squared plus y2 minus y1 all squared, okay? So your distance is the square root of 80. So you've got root 80. It's equals to the square root of x2. You can take the x2 to be minus 7, right? Minus x1, it's minus 3. And then you square the results plus y2. Now, be careful here. You've got the minus 7. This is what you said, x2, all right? So it means this is your y2. If this is your x1, this is your y1. So you've got y minus 4. And then you square the results. Okay, guys, you've got a square root on the left-hand side and then a square root on the right-hand side. So you can square on both sides. If you square on both sides, you get 80 equals to minus 7 plus 3, square the results, plus y minus 4 all squared. All right. Right now, let's fix this. This is 80 equals to minus 7 plus 3, that's minus 4 all squared, that's 16 plus y minus 4 all squared. And then it's either you multiply out your y minus 4 all squared and you factorize trinomial and so forth, or you take this across, then you've got 80 minus 16, so for 64 is y minus 4 all squared. And then how do you remove that square? You are going to square on square root on both sides. Now remember, when you square root on both sides, you are giving a square root yourself, so it's going to be plus or minus. So this will be your square root, so that's plus or minus. And some of you will just take it and use the difference of two squares. So the plus or minus root 64 is plus or minus 8 equals to y minus 4. So it means that our y is 4 plus 8 or 4 minus 8. Therefore, your conclusion would be y is 12 or y is negative 4. But if you've drawn a picture, you'll see that there will be two possible y values there for that minus 7 and y, and then minus 7 and y, but going to that point. Okay, so we're going to have a break, and then we continue after the break. Just go get some water. Welcome back, wonderful grade 11s. We continue with our coordinate geometry. The next question is asking you to calculate the coordinates of the midpoint. You must always highlight your important points there. Of the line joining the points 4, minus 1, and minus 1, 3, and then B, 0 and 0, and then the other one is 3 and minus 8. I'm giving you 2 minutes, strictly 2 minutes to work on these two programs, and then problems we're going to run through as quick as possible. 2 minutes, guys. That was wonderful, grade 11s. Let's just see if most of us have got the correct answers. Okay. Sorry. Calculate the coordinates of the midpoint of the line joining these points. Okay. Midpoint is at x1 plus x2 over 2 is to y1 plus y2 over 2. Right. So x1, if you're saying this is your x1, so that's going to be 4. X2 would be minus 1 over 2 is to y1 is minus 1, y2 is plus 3 all over 2. And then we normally represent it with m. So m is 4 minus 1, that's 3 over 2 is 2 over 2, which is a 1. Well done to you guys who got the 3 over 2 and 1. That is the correct answer. And now we look at the next problem. Okay, so what's the point halfway through between 0, 0 and 3 and minus 8? So you've got your m bracket. Let's say this is your 1 and that's your 2. So you've got a 3 plus naught over 2 is to minus 8 plus naught all over 2. So your m is 3 over 2 is to negative 4. So the midpoint of 0, 0, 3 and minus 8 is 3 over 2 and minus 4. All right? So now, guys, earlier on in our lesson, we spoke about the gradient, parallel lines, perpendicular lines, and so forth. Now, the next set of problems, which we're going to run through very quick because you're getting used to this thing now, you need to calculate the gradients of AB and CD in each case and state whether AB and CD are parallel, perpendicular, or neither parallel or perpendicular. So you've got 3 problems. I encourage you guys to work very fast, and I'm giving you 3 minutes to work on these problems, and then we can tackle them as quick as possible. Well done, grade 11s. Let's just now see if you are getting these things right. Okay, we need to tell whether these lines are sorry, sorry, these lines are parallel or perpendicular. Okay, sorry. Calculate the gradient of AB and CD. All right. In each case, and state whether AB and CD are parallel or perpendicular. All right. Let's start with this one. You've got the gradient of AB. Gradient of AB would be given by -1 minus 5 divided by 5 plus 3, which is -6/8, and that is -3/4, right? Now, we work out the gradient of CD. That's 3 plus 1 over 1 plus 3. Now remember, for these two, to tell if they are parallel, they should have the same gradient. And if the product of their gradients is equal to -1, then we'll conclude by saying they are perpendicular. So you get 4/4, and that is 1. Goodness, they are not the same. And number 2, if you multiply the two gradients, you don't get a -1. So for this particular problem, they are neither, okay? Because we don't get the same gradient, or when we multiply the two gradients, we get -3/4, which is not -1. Okay? Right. Now the next problem, you've got the gradient of AB is 1 minus -4 all over 3 minus 2, which is a +2. And that we get 5 divided by 5, and that's a 1. All right? Now we check with the gradient of CD. Your gradient of CD is -8 plus 1 divided by -2 minus 5. And that is -7 divided by -7. And that gives us a 1. Now, look, something interesting here. The gradient of AB is 1, and the gradient of CD is 1. So you have, your lines are parallel, they share the same gradient. So we can conclude by saying, therefore, for this case, AB is parallel to CD. Why? Because gradient of AB is the same as gradient of CD. Okay, right. Now we look at the last one, this particular set of problems. Calculate the gradients of AB and CD in each case. So in this set of coordinates, so your AB is this. So gradient of AB will be 4 minus 1 over 2 plus 2. Now remember, I am quickly changing the sign because I'm saying x2 minus x1. So that's x2 minus 2. So a negative and a negative, it's a plus. So you get 3 divided by 4. So for gradient of AB is that. And then gradient of CD is 3 plus 1, all divided by 0 plus 3. And that is 4 over 3. Okay, so let's just check. This is 3 plus 1 over 0 plus 3. So you get 4 over 3. And then on the other side, you've got 3 over 4. Now, let's just check. Are these lines parallel, perpendicular, or neither? You're getting 3 over 4. On the other side, you get 4 over 3. Condition number 1, if parallel, they share the same gradient. Okay, 3 over 4 is not the same as 4 over 3. Number 2, if the product of the two gradients is equals to -1, then it means that they are perpendicular. Let's check. Gradient of AB times gradient of CD, it's equals to gradient of AB is 3 over 4 times 4 over 3, which gives us a 1. Now watch, guys. We always make a mistake here and saying, okay, because I'm getting a 1, so it means that these lines are perpendicular. It's not. If we had, like, if we can take this scenario here, if the gradient of AB was 3 over 4, and the gradient of CD was minus 4 over 3, then we can make that conclusion by saying this is 3 over 4 times minus 4 over 3, and that is a negative 1. So the product of the gradients is negative 1. Then the two lines are perpendicular. All right. Now, let's move on. All right. Now, you need to determine the equations of the following lines. Okay. The first one is with a slope of minus 3 and the y-cut of 2. And then the next problem, okay, you can take it down quickly. Determine the equation of the line which is parallel to this line, y minus 3x minus 2 equals to 0, and passing through 3 and 1. So we'll work with those two problems. I want you to work a little bit fast because this is an easy section that we're doing. So you've got y minus 3x minus 2 equals to 0, and passing through 3 and 1. So take that question down. And then you also have this one with a slope of minus 3 and cutting the y-axis at 2. So I'm giving you 2 minutes again, guys. You work on these two problems, and then we can work together as well. Work with your partner, and then let's get back in after 2 minutes. Let's check if you are right or right, grade 11s. You put it in a standard form, y is 3x plus 2, and you need a line parallel. They will have the same gradient and passing through 3, 1. So y minus y1 is m into x minus x1. So y minus 1 is m is 3, x minus 3. Then you get your equation is 3x minus 9 plus 1. So y is 3x minus 8. So for this one, your solution is that. And then this one, your m, you have mx plus c. Your m is minus 3. It cuts at 2. So your y is minus 3x plus 2. So y cut is 2. So well done, guys. Those of you who've done this correctly, just displaying this one, the second one, your gradient is the same throughout. Put it in a standard form, and then you substitute the 3 and 1. And as I said, this is an easy section. Guys, You are going to make it. Let's keep on working hard, and we are consistent, and we're asking questions each and every day, and we do every day 2 problems or 3. Thank you very much. See you next time.